Here we have an algebraic fraction where not only are these not the same, but we have pluses and minuses floating around within the numerators and denominators. And this really changes the game. Because when you look at something like this, what I want you guys to understand is that this x, it's not like this x and this 1 are separate things. This is an x plus 1, and this entire thing it's kind of its own thing, and this x is its own thing. And that affects us when we have to go to try to find the least common denominator. When I try to find the least common denominator, what I basically have to do is consider each part of this its own thing, and if I have an expression that's in my denominator, it needs to be in my common denominator. So here's what I mean. When I look at this fraction, x plus 1 is in this denominator. That entire thing, x plus 1, is in the denominator. So that means my LCD has to have an x plus 1. When I look at this fraction, it has an x in the denominator. So I have to look at my LCD and decide, does this have an x? And by x, I don't mean an x plus 1, but I mean an x that's all by itself, just an x by itself. And of course, there's not. So I have to include in my LCD another x. So this would be my LCD, my least common denominator, and my next step is to take this fraction and make sure that whatever the denominator is missing, I give it that missing piece. So for example, when I'm considering this 3 over x plus 1, I consider this guy's denominator as x plus 1, I compare it to the LCD, and it's missing an x. It doesn't have just an x. So that means, as the person doing the problem, I've got to include another x, and I've got to balance it out by putting another one on top. Then, oh, we have a minus sign here. That's going to trip us up a little bit, but I'll do that in a second. Always be careful on those minus signs. The second fraction, 2x plus 1 over just plain old x, I look at this guy's denominator, I compare it to what that LCD should be, and I notice it's missing an x plus 1. So now I have to include a whole x plus 1. I can't just put a plus 1 on there. It's got to be x plus 1, x plus 1. So now we know what we have to do to kind of clean these tops up, but there's a few other things we've got to look out for. So this part's pretty easy, not much to talk about here. 3x over x times x plus 1. For this next part, there's going to be a whole bunch of stuff. We're going to have to do 2x times x and 2x times 1 and 1 times x and 1 times 1 and combine like terms. And then, because of this minus sign, everything's going to have the opposite sign of what it currently had. So why don't you try and do that part on your own real quick, and then I'm going to pause the video, and when it comes back, you're going to see kind of what I have as an intermediate step. So I decided not to apply the negative sign yet, just to show you what happens. After you FOIL this part out, you get this, and we're subtracting that entire expression. So what I really want to be doing next is making this a plus, and then make that negative, make that negative, make that negative. And now that these denominators are the same, we're just going to combine these like terms. So negative 2x squared, he has no friends, poor little fella. 3x and negative 3x, they knock each other out, so they cancel completely. And then this negative 1 here is going to stay on the top. And the denominator is going to be x times x plus 1. Sometimes, if this looks like it might factor and cancel some stuff out, I might try and factor cancel. But I can see that x plus 1 or x is not a factor of this. So I'm going to stop it here, and that's going to be how I do it. So it's all a matter of looking at everyone's denominator, making sure that if it's in the denominator in the problem, it's in my LCD, then going back to the problem and giving each fraction the part that it's missing. And then from there, a whole bunch of old skills take over. Foiling, negative sign distribution, combination of like terms. It's all about getting this right and realizing that these have to match by giving missing pieces. Good luck.